Hi everybody. Today we're going to be talking about translations, which is the first section of the third unit. And the third unit is all about transformations. You're going to see that this is probably going to be one of the easier units for you. It's a lot of information that's typically students have an easier time understanding because it's very visual. And yeah, I think you guys will like it. So we're going to start off with translations. So translations are when you shift something. Okay, so you're going to take an object and you're going to move it. Okay, you're not going to change its orientation, so you're not going to change the way it's positioned in terms of twisting or flipping it. So it's going to be oriented the same manner, but it's going to be shifted in a direction, up, down, left, or right, or a combination of any of those. So anyway, translation is what we call a transformation. A transformation that results in a shift. Okay? Yeah, you'll hear these words used. Let me zoom in a little bit here. You'll hear these words used like shift, twist, or flip, and they confer another word. So translation is the shift. Okay, let's put that there. So shift. Okay? And translations preserve congruency. Okay? And what that means is when you apply a translation to something, the resulting image will be the exact same shape and size as the preimage. Okay? And we're going to get into that in a moment. Translation vector, by definition, is actually the exact same thing as translation. The vector is to do with direction. So we talked a little bit about that when we were learning about distance in both distance formula and absolute value. Okay, distance is considered a vector quantity because it can't have a negative value. It can have a direction, like you can be 5 miles east of somewhere or 5 miles west of somewhere, but you can't be negative 5 feet away from something, correct? So translation vector is really just the direction, all right? And it's pretty synonymous with this. Here is an example. It says, in the diagram below, draw the translation of the figure along with the translation vector ray W. So okay, so this is what we call our preimage. It's a preimage. And that's what you start with. Okay, the preimage is what you start with. And we're going to go down to the left. So this is going to be kind of a rough little, this isn't going to be perfect. So let's see, this is our A prime. A prime, this is going to be our C prime. And this is going to be our B prime. So it's going to look something like this. And again, this isn't like a perfect job, but this is just kind of like a rough idea of how it works. So this is the preimage, and this is the image. And you'll notice the notation I used. Oh, that is terrible handwriting. Let me try that again. Here we go. A little less terrible. Okay, so A prime is going to be the image, B prime is the image, and C prime is the image. You can tell. Let me zoom in here a little bit. I think this is a little blurry. There we go. Okay, so yeah. You can tell the notation here. This indicates that it's been transformed. This is a translation of point C. So this is the pre-image point, and this is the image point. You start with a pre and end up with the image. There's no post-image, it's just pre-image and image. Okay, let's go on and try an example here. So there's different ways of describing translations. There's verbal, there's mathematical, there's vector. Okay, so the verbal one is just literally in words. They're going to say, okay, quadrilateral, D, E, F, G. That's what this is. This is our pre-image. We're going to go 3 down and 6 to the right. So 3 down and then 6 to the right. So let's try that. 3 down, 6 right. So 3 down. 1, 2, 3, and then 1, 2, 3, 4, 5. And we're going to go off the grid here. Not a great example because we're going to go off the grid actually with 2 of these points. And that's our E prime, okay? Then we're going to go down 3. So 1, 2, 3, then 6 to the right. 1, 2, 3, 4, 5, 6. And that's going to be our D prime. And then G, we're going to go down 3, 1, 2, 3, and then 1, 2, 3, 4, 5, 6, and that is our G prime. And then our F, again, this is going to go off the grid too. 1, 2, 3, 1, 2, 3, 4, 5, 6, and that is our F prime. Zoom in a little more here. There we go. Okay, and if we connect these, the resulting quadrilateral should be congruent to the preimage. So we're going to label this as our pre-image, and this is our image. Okay? So we went down and to the right. Now, if we were to write this with coordinates, let's go ahead and do that. Let's actually label our coordinates here. So let's look at our coordinates. This is D, so D, E, F, G. So the coordinates of D are, let's see, 1, 2, 3, so -3, and then 1, 2, 3, +3. And then E is going to be 0, 3. F is going to be 1, 2, 3, -3. And then down 3 is -3. And then G is going to be -4, +1. So those are the coordinates of our preimage. And when we apply our translation, those are going to change. So we have D prime, E prime, F prime, and G prime. Okay, so D prime is going to be 1, 2, 3, 3, 0. E prime is going to be 6, 0. F prime is going to be 3, -6. And G prime is going to be 2, -2. Okay? Now, if you figured it out, you can actually figure this out mathematically by looking at the directions here. So down affects the y value, right? And if we're going down in the y value, our y value is getting smaller. So you could think of this as actually y minus 3. Okay? If we're going 6 to the right, well, that means if we're going to the right on the x-axis, our x value is increasing. So this would actually be x plus 6. And this kind of leads into the other format. But you can actually check this. Look, so x plus 6. So -3 plus 6 is 3. That worked. And then we're going to subtract 3 from the y value. So 3 take away 3 is 0. You can see how this mathematically translates over here. Okay? Okay, let's check out this other one here. So that was the verbal method, but this kind of led into the coordinate notation method. So translate triangle JKL, and then they give us the coordinate notation method. And they actually give us the points, the preimage. So let's go ahead and do that. So we're going to subtract 5 and add 4. So 2 take away 5 would be -3. So J prime is -3, comma, and then -4 plus 4 would be 0. Okay. And then K prime, so 3 take away 5 is -2, and then -2 plus 4 is +2. Okay, and then L prime, well, that's not an L, what the hell is that? L prime, so 5 take away 5 is 0, and then -5 plus 4 is -1. Okay, so those are the coordinates of our image. Let's go ahead and graph that. So -3, 0. 1, 2, 3. That is our J prime. And then -2, +2. So 1, 2, 1, 2. That is our K prime. And then our L prime is 0, -1. So down here. Prime, okay. And there we go. So you can see this went up and to the left. The vector would actually be that way, right? Down here, the vector would be that way. All right, so that's pretty straightforward, I think. I think it should make sense, I hope. So those are 2 ways of doing it. Now we're going to go ahead and take a look at the vector notation. So the vector notation is something you typically just don't really see very often, but it's a good idea just still to see it. You can think of it like this. So if it's positive, we're going to be adding. If it's negative, we're going to be subtracting. You could think of this as you could really just think of this as x plus 2 and y minus 1. Okay? We have -5, -1, -4, -4, and -3, 0. Okay? So we're going to go ahead and graph the preimage first. We'll make that in blue. So -5, -1. So 1, 2, 3, 4, 5, -1. And that is our E. And then we have F is -4, -4. So 1, 2, 3, 4, 1, 2, 3, 4. That is our F. And G is -3, 0, so 1, 2, 3. And that is our G. Oh, no prime, what am I doing? Okay, so let's go ahead and connect those. And then we're gonna apply this to it. So I'm gonna go ahead and write this actually this way. I think it's easier, honestly, if I like seeing it the way I'm gonna write it here. For me, it makes more sense. Okay, so -4, -4, and then it's gonna be -3, 0. So we're going to apply the vector notation to it. So we're going to add 2 and subtract 1. So add 2, so actually I'll write it like this. 2, -1. So this will become -3, and this will become -2. This will become -2. Oh my gosh, I almost forgot the notation. So F prime, and then G prime. So this will become -2, and this become -5. and this will become -1, and this will become -1. Okay, so those are the coordinates of our image. Let's go ahead and graph those. So -3, -2. So 1, 2, 3, 1, 2. That's our E prime. And then -2, -5. So down here, it's going to be our F prime. And then -1, -1 is going to be our G prime. So you can just check this. So we went down to the right, down to the right, down to, yeah, that works. So that was the vector that way. Okay, so that's how you use vector notation. Yeah, so those are the three ways you're really going to be seeing it. Now we have describing the transformation. So we're given a translation, like we translated this way, right? You can tell because these are the primes, right? So we know this is the preimage. Let's label that preimage and image. Okay, so we're going this way. Let's pick a point. We're going to start with, we'll do Q. We only need one to do this. So we're starting here. We're going to go down and to the right. So how far down did we go? We went 1, 2, 3, 4, 5. So we went down 5. So down 5. And we went right 2. 2. That's our verbal method. Coordinate method, so x, if we went right 2, we added 2. If we went down 5, we subtracted 5 from y. Okay, so that's our coordinate method. In vector notation, you can just literally take these numbers here, so 2, -5. Okay, pretty straightforward. All right, so the homework is really going to be just the two things we did. It's applying the translations and identifying the translations. Okay, the last page of the notes here, we have write a rule for the given translation. So again, you can just pick a point. So we'll go ahead with Q. So we look what happened to Q here. So we went 0 to -5. So we subtracted 5 from x, because to go from 0 to -5, you subtracted 5. So pretty straightforward. So go from 1 to -3, we have to subtract 4. So y minus 4. Okay. You could also write it like this. You could say left 5. And down 4. And you could also say -5, -4. Okay, let's try this one. So these, let's use the g's, I guess. So to go from g to g prime is -1 to 0, so we added 1. So x plus 1. And to go from 1 to -5, we subtracted 6, so y take away 6. Okay, and let's do this in the verbal method. So write 1. And we went down 6. And let's see, we'll do the vector method. So it's going to be 1, -6. Okay. So yeah, now we're going to go ahead and do some more graphing, and we're going to finish it up. So find the coordinates of the vertices of the graph for each translation. Okay, so we're going to try to identify the actual coordinates, but we're going to graph it too. So yeah, so we're going to leave x the way it is, and we're going to add 1. So in other words, it's going to shift up. We're going to shift up 1. So this is going to be our Q prime. This is going to be our P prime. This is going to be our S prime. And this is going to be our R prime. Okay. Let's go ahead and write that one. So Q prime is going to be 1, 2, 3, 0, 3. P prime is 0, -1. R prime is 1, 2, 3, 1, 2, 3, so 3, 3. And S prime is 1, 2, -2. So S prime is 2, -2. Okay, let's go ahead and look at these. So we have x minus 1, y minus 2. So we're going left 1, down 2. So left 1, down 2, left 1, down 2, left 1, down 2. We're going to connect those. So D prime, E prime, and C prime. Now if you want, you can actually apply these. If you have the existing coordinates, you can just apply that to that and get the coordinates and graph it. I find it quicker here to just apply it to the points and think of it as direction, but do it however you want. There are going to be some problems where you have to write the coordinates first, but for these cases, you're not being required to do so. So let's go ahead and write the coordinates of these new points. So D prime, E prime, and C prime. So D prime is going to be, -4, 0. E prime is going to be -5, -3. And C prime is going to be -3, -5. If at any point you notice that your image and your preimage don't match up, it means you made a mistake. So if this shape didn't look the same as that, I would know that I somehow made an error and have to go back and find out what it is, okay? It's one of the nice things about this. Usually it's visually very telling if it's accurate or not. So this should be the notation for a vector, but I don't know why it's not. So 0, -2. So the x is not changing, but the y is decreasing by 2. So we're going down 2. So that's y prime. This will be z prime. This will be w prime. And this will be x prime. So let's connect those. We should have a matching quadrilateral, which we do. So y prime is going to be -4, 0. X prime is going to be -1, 1. W prime is going to be 0, -3. And z prime is going to be -3, -2. Okay, and the last one, -5, 1. So we're going to subtract 5 from the x and add 1 to the y. So if we're subtracting from x, we're going to go left 5, and we're going to go up 1. So 1, 2, 3, 4, 5, up 1. That's our r prime. 1, 2, 3, 4, 5, up 1. That's going to be our s prime. 1, 2, 3, 4, 5, up 1. That is our q prime. And 1, 2, 3, 4, 5, up 1. That is our p prime. I would recommend using a pencil for these. I'm using a pen so you can see it better on the camera, but the problem with using a pen is if you make a mistake, you can't fix it. You just can't, unless it's an erasable pen. So you really want to be using one of these. The only reason you use a pen is so you can see it better on the video. All right, so let's go ahead and label these points, and we're done. So q prime is going to be 0, +4. P prime is going to be -1, -1. Okay. S prime is going to be -5, -2. And R prime is going to be -5, +2. And let's take a quick look. Yeah, it looks congruent. So, all right, so that finishes it up. Hopefully that was helpful. It's a lot of notes, but I think the concept should be pretty straightforward. And yeah, let me know if there's any questions you guys have. Thanks for watching, guys.